Hello, everyone. Good morning, good afternoon, and good evening. So my name is Shinichi Nakasuka. I'm very happy to see you again tonight. And so I'd like to show some introduction to the PreMIC8 workshop. As you know, the Mission Idea Contest 8 will featuring the constellation and the formation flying mission design. So tonight, I'd like to show some introduction to these issues. So the first, I'd like to talk about constellation. Maybe, as you know, why the constellation is required. So if you know, maybe as you know, that the LEO satellites has a very good, capability of the high spatial resolution, like a 0.3 meter to 30 meters. But the problem is that time resolution is several days or 40 days. That means every several days or 40 days interval is required to come back to the same place. And several hundreds of satellites will be required for less than 1 hour time resolution. That is a very big issue for the LEO satellite. On the other hand, we have a GEO satellite. So there is not so many GEO Earth observation satellite, but the Himawari meteorological satellite and the few satellites have this capability. And it has a continuous monitoring possible, and the high time resolution will be achieved by quick scanning. For example, the Himawari can scan over the whole globe at every 10 minutes. But the problem is that it is far away from the Earth, so that results in the low spatial resolution. So how we can combine these two good merits of the LEO and the GEO satellite? That is one solution is to have a constellation of many LEO satellites, which can compensate for the lack of the time resolution. So this is a reason why we need a constellation. So as you know, there are several mega constellation is already, for the business, is going on for the business. And the Starlink already launched more than 3,000 satellites, and they are targeting to more than 10,000 satellites to constitute a certain kind of the internet in the sky. And not only just Starlink, but also the many other company is now targeting the communication type of the satellite constellation. And as you know, currently the big GEO satellite, geosynchronous satellite, and the LEO constellation satellite coexist. And some satellite has a PNT, position, navigation, and time information. And so there are many types of this kind of the large constellation of the communication satellite appearing. And as to the Earth observation field, maybe as you know, the planet already launched more than 203 CubeSat to have a very high time resolution of the Earth observation. So this kind of the image can be obtained at every 5 to 8 hours, which can provide a very good information for the change of the Earth's surface. And in Japan, we have several, such kind of the company which are targeting the small satellite constellation. For example, Accel Space, which is a startup company from our laboratory, is targeting to have a 10 to 20 satellite constellation to be by the 2002X. And the satellite is called the GRUS, which has a 2.5 meter resolution. And this kind of the picture has been obtained, and they launched additional 4 satellites last year. And they have now the 5 satellite constellation, and every 2 or 3 days as coverage can be possible. And the next company is Senspective, which is also the one of the startup company from our laboratory, and they are also targeting the 20 to 30 satellite constellation by 2025. And their first satellite, Asterix Alpha, was launched in 2020, and they could obtain this kind of the first flight in 2021. And the Asterix Beta was also launched on this March the 1st, and they now have the 2 satellites, but they are targeting to have a 22 satellite in order to obtain high time resolution. In the field of the meteorological or IoT, we have the UNISEC-Global company, which are targeting to obtain the high time resolution satellite constellation in order to obtain the GNSS occultation observation, which can be used for the weather prediction. And so the data is now sold to the NOAA. And the Meteota is targeting to obtain more than 25 3U satellite constellation to receive very weak signal from the ground. That is a kind of the IoT communication application, which can be used for agriculture, transportation, defense, and mining application, and so on. So now I'd like to summarize the merits of the constellation for the various missions. As to the Earth observation, the constellation can obtain the high time resolution. That means a more frequent observation would be possible. It also has some resilience. That means robust against satellite damages and loss. And if there is a satellite cross-link, maybe the quick data downlink will be also possible. As to the communication field, it can connect all over the world by multiple cross-links between the satellites, and the strong merits as to RF power requirement and latency because the satellite is a low Earth orbit and the distance is not so large. As to the navigation, position, navigation, and time information can be distributed from the low Earth orbit satellite, and as a result, received power can be stronger, and also you can use the GNSS information even in the in-house. And the quick convergence of precise positioning can be possible if many moving satellites can be seen from the ground. And these are the high time resolution type of the merits, but also we have the another type of the merit, that is a quantity of developed satellite and iteration will be huge. Then we have a very good merit of the number of iteration. So this R means a kind of the improvement of the performance or reliability. It can be a kind of the 1 plus y to the power of t. And in the current space technology, we don't have much occasion of the satellite development and launch. That means we want to improve the y in order to obtain the high R. But in the field of the IT, y is not so large, just like a 0.01 or so, but the small t is very large. That means a frequent iteration can provide a high, improvement, rate. So this kind of the thing is happening in the SpaceX business, and Elon Musk is saying that if things are not failing, you are not innovating enough. That means the challenging is very important. And fail, even if the fail, quickly the next rocket will be launched, and then this kind of iteration can provide a very fast growth of the technology. So this is another merit. Okay, and let us discuss the design of the constellation. First, you should do. First thing you should do is to find a clear objective to use a constellation, okay, as I said before. And then you should design the revisit interval. So mission will decide the required interval, 1 hour, 1 day, or 1 week, 1 month, and so on, and which decide the number of satellites and object orbital planes, height, satellite phases in each orbit, and so on. And also, we should do the trade-off of the number of satellites and the total cost. And also, you should consider the latency of data link. Mission will decide permissible latency. So latency means time between the obtaining of the data and the downlink to the ground. 30 minutes, 1 hour, 6 hours, and so on, which decides the number and position of ground stations. And the design of satellites themselves are also required. And maybe you have the heterogeneous or homogeneous satellite constellation, and also you need some additional design for cross-link or constellation operation. Let me show some example of the Japanese anti-disaster type of the constellation. As you know, the Japanese space agency JAXA is providing a very good program of Earth observation called the AEROS. It is a very big satellite, a 2-ton, 4-ton satellite will be launched every 7 years, which can provide a very good information of the ground. But in order to obtain the disaster management, prevention, mitigation, then we need to design the constellation very carefully. So we get information that as to the requirement from the disaster management side. So the first information on disaster areas should be delivered at least before 12 hours after the disaster occurring. So this is to find out where to send rescue teams. So 12 hours is a very important number. After that, periodically, the information of the specific areas should be delivered with interval of 3 to 6 hours. This is to monitor the area after disaster. And of course, all weather 24 hours information is important. So the Eros 4 type of the satellite, which has a very large observation swath, would be very attractive. But only one satellite is not enough to obtain high responsiveness and time resolution. That is less than 12 hours or 3 to 6 hours. So we need to design a constellation in the initial phase, in the finding out phase. That can be done by governmental satellite or small satellite constellation, and the monitoring can be done by buying small satellite constellation images and so on. So this kind of the constellation should be designed in order to meet the requirement from the user side. So now let's move on to the formation flying. Formation flying is a technology for coordinated control of multiple spacecraft flying near to each other. And it may realize high-level astronomical or Earth observation missions that would not be possible with a single spacecraft. The example of the mission looks like this: Earth observation with several satellites, or astronomy or astrophysics observation using the 3 satellites or 1 straight line, 2 satellites, and so on. So this is very suitable for micro, nano, pico satellite, as their capability as one satellite is limited, but we can realize high level mission. So it is very suitable for the micro, nano, pico satellite. And also the mission and the accuracy level of the FF has a very intimate, very close relationship. Currently, the relative position control accuracy of centimeter to meter was achieved by several satellite technology, and the millimeter class formation flying mission are now going by the Probus 3 from a European agency. But high accuracy, like a micrometer to millimeter level, will make interferometer or synthetic aperture mission possible. But still, low accuracy, like a centimeter to meter level formation flying, have some useful missions. So please consider at what accuracy level you can obtain what kind of the missions. And let me show the several example of the formation flying mission. One example is a series which we are now under study. It is infrared science formation flying. So we have a several success level. In the minimum success, mother satellite and the 2 daughter satellite launched all together. And in the full success, the light is coming from this red direction. And then the light is mirrored at these daughter satellite and converged in the mother satellite, and to obtain the interferometric observation, to obtain very good image of the, for example, the this kind of the solar system object and so on. So in this satellite, by using densified pupil spectroscopy, the required accuracy of formation flying will be much relaxed to millimeter level. That is a concept of this series mission. The next one is a straight line formation missions. For example, in the Starshade mission, so we want to obtain the observation of the exoplanet, but the big problem is that we have a central star that emit a lot of very light, very strong light. So we should occult this central star to obtain the information from the exoplanet. That is a concept of the Starshade mission, and we need this kind of the receiver satellite and the occulter satellite. And in the X-ray telescope interferometer. So this is, for example, X-ray source. And we have a 2 satellite, and which can have a long focal length, something like X-ray optical system to obtain the high resolution of this X-ray source. So in this kind of the straight line formation case, we should consider how to keep the straight line formation using some delta V and so on, and how to change from one target to another target using for the multiple targets. So another application is a synthetic aperture telescope. So this is also the satellite system which we are studying. So we put this kind of the six satellite in the geostationary orbit, and then the light will be reflected by these six satellite meters and then converge to the main satellite, imaging satellite. And with this type of the synthetic aperture, we can obtain high resolution, spatial resolution on the ground. So it can virtually configure large aperture. Using this kind of the technology, we can obtain high time resolution and scalable low-cost operation flexibility, and virtual aperture can be large and always able to communicate with ground station because this satellite is in the geosynchronous orbit. So we have many this kind of the merits. So this kind of the system is worthwhile studying. So let me summarize the important things of the formation flying. Interferometric observation would be possible if we, for example, if we have a two antenna and the RF is coming from this direction, then if we measure the phase difference of just two antenna, then we can obtain high, how can I say, a good high-level information as to the direction of the incoming RF, and that means improving resolution. And the other one is realizing long focal length. The light is coming from here, and we have a lens or occulter satellite and the detector satellite here. We can have a long baseline between these two satellites. And also the synthetic aperture telescope as before, it can virtually realize large aperture telescope, which can obtain high spatial resolution. And the another one is a simultaneous observation at many points. Observation of the particle, magnetic field, gravity, or electric potential would be possible. So how we can do the design of the formation flying? First, you should find out clear objective to use formation flying, as I said before. Then we should define mission requirements, accuracy, observation duration, and aperture size. And the satellite quantity, position distributions, and the sensor would come, follow. And then define the shape and accuracy of the formation, planar formation, straight line formation, cartwheel formation, and so on. And the required position and attitude accuracy should be derived. And how to realize or keep the required formation is the final questions. And then you should design the satellite as usual. So that's all. And finally, I would like to skip this. And the PreMIC8 to be held in Istanbul, we will provide a mini lecture or workshop on how to design this kind of the constellation or formation flying missions. And assuming certain missions like constellation of Earth observation or formation flying of interferometric observation and so on. So join us at UNISEC-Global meeting in Turkey to be held in this October. Thank you very much. That's all.